When solving equations, the goal is to isolate the variable. This means that the variable should be by itself on one side of the equation. We are going to use models to show how you can isolate the variable. This equation says x plus 3 equals 8. I'm going to use algebra tiles to model this. So I'm going to use an x algebra tile, which is always green, and I'm going to show that I'm adding 3 to that value of x, which I don't know, by putting 3 of the yellow tiles, and each yellow tile represents one whole. Now I know that when I add x plus these 3, I'm going to get 8. So I'm going to put an additional 8 on the other side. Now I know that an equation is like a balance beam. And anytime I add or take away from one side of my equation, I have to do the same thing to the other side to keep it balanced. I know that I want x to be by itself on this left side of the equal sign, which means I'm going to need to get rid of these 3 ones. Well, I can't get rid of these 3 ones on the left side unless I also get rid of 3 ones on the right side, because every time I do something to the left side, I must also do the same thing to the right. So now I'm going to take away 3 of the ones from the right side. Now what I see is that I'm left with x by itself, and now I know that x is equal to, and I have 5 of my ones here. So the value of x is that x equals 5. I can also use bar diagrams or tape diagrams to show solving equations. This equation says x plus 12 equals 19. When I use a bar diagram, I'm going to start with just a bar, and then I'm going to split it into what I know. The first thing that I know is that this whole thing is equal to 19. So I'm going to show that by putting these brackets and showing that the whole bar is equal to 19. Then I know that I don't know what x is, but I do know that x is being added to 12 and that that value is equal to 19. So what I'm going to do is split my bar up into a value of x and 12. I know that both of these together will give me a value of 19. Now to solve this, I need to look at what I have. I notice that I am adding x to 12, and I notice that this whole thing gives me 19. Well, I need to figure out what x equals. To figure out what x equals, I need to get rid of my 12. So what I can do is subtract 12 from 19 to show me what I'm left with for x. Well, if I subtract 12 from 19, I get 7. So that means that x equals 7. I can show this on my equation because I know that x plus 12 is equal to 19. I can show this by saying that I would subtract 12 from x, and I also would subtract 12 from 19. If I do that, my 12 minus 12 is 0, and x plus 0 gives me x. And then 19 minus 12 gives me 7. So I get x equals 7 by using the inverse or opposite of adding 12. Next, I see that a board measures 15 feet and is cut into 2 pieces. One piece measures 7 feet, and what is the measure of the second piece? Well, I'm going to use a model to show this problem, and the first thing I'm going to start with is the whole board. I know that the whole board has a measure of 15 feet. Then I know that it is cut into 2 pieces. One of those pieces measures 7 feet, and then the other piece is the measure that we don't know. So we're going to use the variable x to represent that unknown value. Now, if I need to get x by itself, I would need to get rid of 7. The first thing I want to do is write an equation that shows this. This says that if I take 7 and add to x, I'm going to get a total value of 15. So my equation here is 7 plus x equals 15. Now to figure out what x is, I know that I need to take 7 away from x, which means I also need to take 7 away from 15. And if I do 15 minus 7, I get 8. I can show this in my equation by subtracting 7 from both sides of my equation. When I do this, 7 minus 7 gives me 0, and 0 plus x is just x. Then I would bring down my equal sign, and 15 minus 7 is 8. So x is equal to 8. Next, I see that Ben bought 3 sodas for $5.34. How much did each soda cost? Well, the first thing I'm going to start out with is what I know, which is that the total cost was $5.34. I don't know how much each soda cost, but I know that there were 3 of them, so I have 3 unknown values. Together, those 3 unknown values give me $5.34. So what I see in my bar diagram is that I have 3 x's, and together they equal $5.34. Now, to figure out what each x equals, I notice that they are split into 3 equal pieces, which means I will need to split 534 into 3 equal pieces. And the operation that I would use for that would be division. So I would divide $5.34 by 3, which would give me $1.78. I can show this on my equation by dividing by 3 on both sides of my equation. If I do 3 divided by 3, I get 1. And if I have 1x, that's the same as just x. So my 3's will kind of go away or cancel each other out. And then on this side of the equation, if I have $5.34 and divide by 3, I get $1.78. So each soda cost $1.78. Next, I see that Kenya and Terry are sharing a bag of lollipops. If each girl gets 12 lollipops, how many lollipops are in the bag? The first thing that I start out with is knowing the total. But in this case, the total is actually what I'm looking for. I know that they have a bag of lollipops, and what I don't know is how many lollipops are in that bag. So I'm going to use the variable x to represent the total number of lollipops in the bag. I know that the bag was split up into 2 equal pieces, and that both of those pieces are equal to 12 because each girl gets 12 lollipops. I can show this on an equation by saying that x was being divided by 2 equal pieces, and each of those equal pieces is 12. Now, to figure out what the value of both is, I know that I have 2 12s, so I can multiply 12 times 2, and I can get 12 times 2 equals 24. So the value of x is 24. I can show this on my equation by multiplying by 2 on both sides of my equation. On this side, if I do x times 2 divided by 2, my 2 over 2 makes 1, and 1x just gives me x. On this side, I have 12 times 2, which gives me 24. So this means that there is a total of 24 lollipops in the bag.